I hope you can hear me. I hope you can see my screen as well. Fine. So let's get started, everyone. Once again, a very good morning, good evening to all of you joining me here on this session. I welcome everyone to the MLOps learning MLOps here. And today is our demo lecture where I'm going to go ahead and talk about the MLOps. So to make it very simple and easy for all of you to get connected, let me first define what is MLOps. So to understand MLOps, let's go ahead and break down the MLOps into two parts. That is ML from the machine learning and the operations from the DevOps. So that's how the word MLOps came into picture. So the definition of MLOps is machine learning operations. That means the machine learning engineer will go ahead and write the machine learning code, and the DevOps engineer will now become the MLOps engineer who will take the responsibility to deploy that code. Am I good to all of you people? So the way that you can relate with the definition of MLOps is very simple. ML will take care of machine learning, the code which is required to be written for machine learning. So when you want to go ahead and do MLOps, it is your data scientist, developer who will write the code for ML, for your machine learning, and the ops. So let me give an example to make it very easy. Let me take you to a very popular data set that is for Kaggle. And in that, let me go ahead and take you to a datasets folder, and let's go ahead and use some dataset like California housing dataset. This is a very popular dataset. So let's look out the datasets. So participants, if you want to visit this URL, here is the link with regards to URL. You can visit this link. Okay. Now, what I want you to understand here is, I want you to understand a file that I have, which is a name of the file is housing.csv file, where if you scroll down, there are various features of the house, where exactly it is located, the latitude and longitude of the property. How old is your property? What are the number of rooms in a given block? What are the number of bedrooms in a given block? How much is the population of that block? How many people are residing in that block? What is the income for that household? What is the value of that, and how close it is to ocean? So these are some values that are taken in this CSV file. There is a CSV file. Now participants, when a machine learning engineer is expected to go ahead and build a model for it, he will go ahead and take into consideration maybe somewhere around like how many rooms, how many bedrooms, what is a population household. We call them as features. We take them as features, and we'll decide the value out of it. So the real value versus prediction. We expect it to do predictions. Participants, am I with you? Hello?
Yes.
We can hear you.
Okay. So the point that I want you to understand here is we go ahead and use data like this data to train our model. What is training? Training in the sense, with all these values from the data, we will try to fit our data. We'll make some fitment with the data. Okay, let me give another example to make you understand the fitment. We all know in our schools, we learned about linear or quadratic equation of a straight line. What is quadratic equation of a straight line? The quadratic equation of a straight line stands out to be y is equal to mx plus c. Hope you remember in your school days. Y is equal to mx plus c. That means if you put your x and y, then y is equal to mx plus c. Y means what you are trying to identify is some times value of x plus c, where m is your gradient, that what is the slope of your line. C is a constant. A c is a value where it hits your x-axis, the intercept. Participants, everyone, are you with me? Hope you recollect your school. In your class 8, you might have seen this. The quadratic equation of a straight line is equal to y is equal to mx plus c. That means the one that you're trying to find, if you try to fit into a straight line, this may look something like this. The property value, the house value is equal to some m1 times the number of rooms plus m2 times the area of the property plus some constant value of c. So participants, now this is a example that I'm trying to give you. The house value is equal to m1 times based upon this relation. So based upon this relation, so what we are trying to go and highlight with y is equal to mx plus c, with y is equal to mx plus c, the simple school mathematics with regards to straight line, the housing property, the house value for this Californian dataset can be figured out as some m1 times the number of rooms you have plus some constant value c. This is why x is rooms and c is the intercept when you put it in a straight line. I hope participants, now you understood how class 8 mathematics you have learned is now useful in machine learning. Participants, everyone, are you with me?
Yes.
Now, based upon this, let's assume that our data scientist builds a model. Data scientist has built the model. What is that model? The model is able to do predictions based upon the number of rooms you have. It is able to tell you the property value. That's a model. That is primarily the machine learning strategy is all about. So machine learning, what machine learning data scientist will do, he will go ahead and develop a model. What is model? Nothing but a piece of code which is able to figure out the relation between the data points. Now, is that very clear, people? The machine learning part is very clear. You have understood the machine learning. Now, let's understand our role as MLOps engineers. So, have you understood primarily the data scientist role? Now, we are called as MLOps engineers. So, what is our role? Now, once this model is developed, we need to make it deployed at a location. We need to make it deployed at a location. So that's where the next word comes into picture. So what data scientist has done? EDA, he has collected all the data, exploratory data analysis, like your data set from Californian data set. He has prepared all the data from the Californian.csv housing.csv file. He developed a model. He trained his model. Now the model is ready. It is given to me. The model is given to me. So now my focus is to deploy that model so that people can go ahead and use it to do predictions. What is my role? My role is to deploy that model. My role is to make that model available for everyone to use. Am I going good, everyone? Participants, am I good? That's how the role of MLOps engineer gets evolved. So the machine learning engineer is expected to go ahead and build the machine learning model for you, the machine learning engineer. But now the ops engineer, the DevOps engineer, the machine learning engineer, the MLOps engineer work together, then that role becomes MLOps. So that MLOps engineer is expected to go ahead and deploy your application. He's expected to deploy that application. Participants, is that a very clear picture to all of you? Participants, is that very clear to all of you?
Yes.
So what are we trying to achieve? We are trying to achieve majorly two things. One, as a machine learning engineer into the MLOps part, we are required to go ahead and write the code for your machine learning. So we'll take the role as ML engineers who develop your model and the ops engineers who deploy that model. So ML engineers means who development they will do. Ops engineers means who deploy that model. Am I clear to all of you people? Participants, have you understood now the role play? If you understand this role play, then learning becomes easy for you. There will be someone who will develop the code for you. Just like development taking place in a Java or a .NET. Have you seen developers writing a code? Yes. What they do, they develop their code and done. But who will go and deploy it? The DevOps engineer will deploy it. DevOps engineer is expected to deploy that code. Am I going good, everyone? Participants, am I going good? So there are two things here. Development done by your machine learning engineer, deployment done by your MLOps engineer. Is that very clear to all of you people? Have you understood now the definition of MLOps very clearly? So I welcome everyone to one of the most and widely growing branch of the DevOps engineering, which is MLOps, where you get to see machine learning modules getting deployed on a CI/CD model. Is that very clear to all of you people? Participants, is that
Yes.
very clear to all of you? So what are we trying
Yes.
to achieve? We are trying to achieve the fastest growing space of DevOps engineering that helps you to deploy your machine learning applications into the environment. What is that environment? Dev, QA, prod, it can be anything. So the machine learning engineers are expected to go ahead and develop your code for your machine learning. That is the primary role. And the ops engineers are responsible for deploying that code, deploy that model. Is that very clear to all of you people? Now I hope you have understood the definition of MLOps. Okay. Now let me go ahead and talk more about the ops part because we are not into the machine learning. We will not do machine learning. But some knowledge of machine learning is very essential because there is no developer. Participants, do we have any developer who will go ahead and help us to write the code? Are you a developer?
So model is what model? Like linear model, so ML engineer.
Correct. So when you come to model, writing of a model, there are various algorithms. Linear
Okay,
regression model.
LLM. Okay.
classification model, K means algorithm. So there can be various algorithms to build your models around the classification, classification and regression. There are two type of models that generally exist: regression and classification. Under the regression, you get linear regression, logistic regression, classification. K means deep forest. So this is purely about machine learning. So what I said, when you don't have any experience in machine learning, it will become difficult for all of you. So for that reason, it is good to have some knowledge built around ML, because we are not developers. That was my ask. What was my question? Are you a developer? No. Do you have any experience in machine learning? If you have, that's fine. If you don't have, it's okay, because we are required to build a model. So for that, some basic knowledge of machine learning is required. Okay, participants, are we good? GNA, I don't have your name, but may I have your name once?
Yeah. Jnana.
Gyan. Okay, fine, sure. Thank you, Gyan. So participants, now assume that we built a model. Just will focus on after the stage. That is, you built a model. So after building a model, we are required to go ahead and deploy that model. So participants, after you build that model, you are required to go ahead and deploy that model. So when you come to DevOps engineering space, deployment is a very, very strong skill for a DevOps engineer. And into the space of DevOps engineering, especially with regards to deployment target, Kubernetes have a very great role to play. Now, I'm not going into the Kubernetes environment, what exactly it is, but Kubernetes is very popular when you target your deployments involving container apps. So if you look into the definition of Kubernetes, that is what exactly being highlighted about. So Kubernetes is basically an open source tool where you can target the deployment, scaling, management of container apps. So remember this word, containerized apps. Participants, everyone are you with me? Have you understood the definition of Kubernetes? So Kubernetes is nothing but a very popular tool which is helpful for you to automate deployment, scaling and management of what kind of applications? Container apps. So now let's connect the dots. So I'm given the responsibility as an MLOps engineer to deploy that model. Kubernetes can help me to deploy that model. But the problem is machine learning code is an ML code, but Kubernetes says container apps. Correct me everyone. The machine learning code is developed by the machine learning engineer, maybe a Python code for now. We'll use Python for our model development. So the Python code, but this Python code is now to be converted into a containerized application which can be used by Kubernetes to deploy as per the definition. I hope is that very clear to all of you people? As per the definition, I can go and use Kubernetes to deploy the application, but that application should be in the form of a containerized application. Any general application, no, I cannot go and use it. So I need to use specifically a container application to deploy that model. That means you should have your model, you should turn your model into a container application, and then you can take that container application to deploy into your Kubernetes environment. Now this module, we call it as Kubeflow. Am I good to all of you people, participants? This module on Kubernetes, we call it as Kubeflow, that helps you to take your machine learning model, turn it into a container application, basically convert into a containerized application and deploy it. So look at the definition of Kubeflow. So Kubeflow is an open source platform for what? Machine learning and MLOps on Kubernetes, which is introduced by Google. So it comes in various stages where it will help you to do the development for your model, model training, model serving, and automate machine learning. So welcome everyone to machine learning and the MLOps engineering using Kubeflow. Is that very clear to all of you people? Participants, now you see how I'm connecting the dots. Where we started? We started to solve the problem via a machine learning. Machine learning needs an advanced step to deploy it. That's how ops engineer comes into picture. That ops engineer is now called as MLOps engineer. So in order to do MLOps engineering, we need a deployment tool, Kubernetes. Kubernetes expects you to bring application, that is your machine learning models, in the form of container apps. Those container apps are expected to be developed by using the module called Kubeflow. So Kubeflow is our expected solution to build our MLOps skill. So have you understood people why there is a need for us to build a skill around Kubernetes followed by Kubeflow? Everyone, are you with me people now? Participants, are we good?
Yes.
So very simple. When you are into the space of MLOps engineer, take your machine learning code, turn it into a image in the form of a container image and deploy it to Kubeflow so that you will achieve MLOps engineering. Now,
So we will
if
be
I come,
having Kubeflow, ML flow, and for AWS SageMaker. Is there any other via?
thank you Gyan, but you're mixing too many things. I'll explain you one by one.
Okay.
Kubeflow is one, ML flow is separate, AWS SageMaker is separate. Don't mix up these things. I'll help you. I'll help you to make you understand. Okay, fine. Now,
Okay.
participants, let's understand if you want to do Kubeflow,
Okay.
what are the targeted modules for the Kubeflow? Targeted modules means where you deploy this Kubeflow. So Kubeflow is available in all the cloud providers. It's available on AWS, it's available on Azure, it's available on GCP, any of a given cloud. Let's start with AWS for now. So in our training, we will be using AWS cloud as a module to go ahead and build our solutions on top of AWS cloud. So if you look into the Kubeflow, now AWS on Kubeflow is available as a solution. May I request the participants, can you please mute yourself for a quick, I'll take your questions. Okay, now Kubeflow on AWS is available. So we can go ahead and use Kubeflow on AWS. Now, Kubeflow on AWS is one module which is very much popular. So companies will ask, what is the kind of experience you have with Kubeflow followed by a cloud provider like AWS, Azure, or GCP? They'll ask you at least one cloud. The companies will ask you. So it is better that you go ahead and build a skill of Kubeflow on top of a cloud provider. But here is a catch. The catch is AWS will charge you approximately $1 an hour, $1 an hour, almost $1. No, it's almost per second. Yes, dollar a second for 1 second. That means if you run for 1 second, uh, is it or dollar or second, I'm not exactly memorizing it, but it will charge you. So let's assume that you are trying to develop a model, and that model development takes, say, for you 2 to 3 hours. That means you have to pay $2 to $3 per model development to AWS Cloud, multiplied by number of days that you want to do, 40 days. That means you'll have to pay somewhere around, on an average, if you spend 2 to 3 hours a day, so somewhere around 2 to 3 hours, right? So 40 hours to 40. So it will cost you somewhere around $1,000. So the calculation I don't remember, but I remember it's cost you something around $1,000. Now, what is my point is that in order to learn something, don't go out and spend $1,000. So what you do, you go out and use a free version of Kubernetes called kind. It's freely available to run your model development for Kubeflow. So if you want to run Kubeflow instead of running in AWS, you can use Kind. So what is that you will do after this? Whatever that you have developed in Kind, you'll just move into AWS. Once your model development is done, once you are able to go and build the model, then you can start taking these models into AWS Cloud. So where you will save almost $1,000. Otherwise, you'll get heavy bill in your account for your AWS account. Since you don't use your organization account, if you use personal account, it will go and charge you. So you have an advantage to go and use in Kind. So I would request you to use Kind as your local machine module and build your modules and build your skill, and then take that skill to the cloud provider AWS, Azure, or GCP. So participants, is that okay for all of you? If it is a confirmation, give me a round of confirmation, everyone.
Yes.
Participants, is that very clear? So try to avoid AWS cloud at the start. Make sure that you completely learn your skill. Then you take that skill to the cloud provider AWS. Yes, Gyan, please.
Yeah, yeah, okay, nothing.
Now, participants, Kubeflow is one part of the story. Have you heard about big data processing, people?
Yes.
Participants, I hope you should have heard about Hadoop.
Yeah, it is
Participants, I hope you heard about Hadoop.
Spark and Scholar, right?
Yes. So, what is this Hadoop and Scala has to do here? I'll explain you. When it is the data, for data to process, we need processing engines. What we need? We need processing engines. So, if you look into the definitions of processing engines, for big data, or put it this way, top 10 processing. You see Apache Spark standing on top. So Apache Spark is your top engine with regards to big data processing. So the company which is responsible for Apache Spark, we it is popularly known as Databricks. Databricks was the company to bring Apache Spark. So this Databricks company now started to focus more on machine learning via a module called ML Flow. What is that they have done is to help machine learning engineers and the machine learning operations team to make their processing engines faster, they brought this concept of ML flow, just like your cube flow, but much more sophisticated, easy to use. So we have this concept called ML flow. So what is ML flow? ML flow is nothing but a very popular distribution engine that is running on top of Apache Spark. So we go ahead and use Apache Spark as a module to go ahead and build your machine learning modules. So this is also a recommended skill for MLOps engineer. So what we have highlighted, Kubeflow, ML flow. Is that very clear to all of you people? Participants, is that very clear?
Yeah.
Now,
Yes.
let me go ahead and bring the concept of the way this module has been developed. So this is a content, participants, where every possible skill that is required for an MLOps engineer has been documented. Now you see whatever I've discussed, I try to narrate the same thing. Some basic concepts followed by some Python learning, because Python is essentially required, but not to an expertise level. Some basic Python knowledge. So you'll understand Python, followed by Python that we'll use for your model development, certain Git fundamentals, where right after this you will start developing the model and you will do the training of the model. That means you basically learn here how to go ahead and build a model. Once the model is done, you will go ahead and focus on Dockerizing that model. Why? Because I said containerized applications. So you need to Dockerize those containers. Once the containerizing of those models is done, you will get started to involve Kubernetes. That's how you will learn Kubernetes. Once you are building a skill around Kubernetes, you'll make an entry into Kubeflow. Once you build your skill with Kubeflow, you will get started with ML flow. Once you build with your Kubeflow and ML flow, then you integrate with your Jenkins pipeline for CI/CD. And for monitoring and uh, we go ahead and use Prometheus and Grafana. So participants, now you are clear with the role play, now clear with the agenda. Participants, are we clear with the role play and the agenda? So now you have a definite path that where you want to go. You want to start to build your skill around Python, from there to containerization, from there from containerization to machine learning module development involving Kubeflow and ML flow, and automating via CAC. Now I have a question. Can you describe airflow and TensorFlow concept? Now airflow is a very popular module which helps you to achieve using Python. Like Kubeflow we are using, ML flow we are using. Airflow is a Python based module. Whereas TensorFlow is nothing but it is a library that is given by Google to build your machine learning models, to build your ML models, or a library for by Google for machine learning framework, ML framework. Clear, Ram? So if you want to go ahead and use Airflow, then you should have good skill in Python to go ahead and use Airflow to integrate your stages. But I see Airflow adoption is very limited, very, very limited. But when you go ahead and look into TensorFlow, TensorFlow is of very different purpose. You build models out of the TensorFlow. You build models out of TensorFlow, which is a Google framework. For example, if you look into TensorFlow, you'll get an idea about it. So what do you do with this TensorFlow? You go ahead and build your models. Let me do this one. Yeah, see here, getting started with TensorFlow. So you're importing TensorFlow to develop a model, compile the model to make it fit, and evaluate it. Are we able to deploy on the same platform and monitor? Airflow, yes, we can do that, but TensorFlow, as I mentioned, it is for a different framework. The idea is very different. Airflow is something that you can make it because it's a Python module, but TensorFlow is a very different. If you want, we can go ahead and do a Kubeflow module involving a TensorFlow, but we need to check out the dependencies, like how TensorFlow can integrate with Kubeflow, how much time will it take. So it's a lengthy process, but yes, we can give it a try.
Does airflow come into picture in this MLOps process?
I would say we can bring airflow also. We can bring airflow also, but you have to justify. It's like this: you are driving a vehicle. When you have vehicle to drive, you'll only drive one vehicle. But if you need to drive multiple vehicles, there is a need for it. So if you say, in my project I'm using Kubeflow, then how will you justify airflow? If you're using MLflow, how will you justify Kubeflow? So you need to have a valid reason for what you have used airflow. My suggestion
Okay.
is we can consider it depending upon the scenario or a need. We can consider it, but we have to have a valid justification for it. Yes, Gyan,
So,
please.
so what exactly TensorFlow? It is running the code or a script or something. So, without Tensor or Airflow, we cannot go with Cube and MLflow.
I think you're confusing yourself with too many things.
Okay.
MLflow is different. As I said, Kubeflow is a Kubernetes module that will help you to develop MLOps engineering solution. MLflow is an Apache Spark based solution for handling MLflow. Now there are two modules that one of the participant Ram has highlighted, which is Python's Airflow and TensorFlow. Python Airflow is almost similar to that of your Kubeflow, to that of your MLflow, but this is a Python module, a community module, not Kubernetes driven or not database driven. Airflow. Now coming up to TensorFlow. What is TensorFlow? TensorFlow is a library. So TensorFlow is a library. You will go and import that library, which via this library you build a model and you try to deploy that model. For deployment, you will use Kubeflow. The model once developed, you will use Kubeflow, MLflow to deploy that model. Now that makes it very clear, Gyan. So look at the word deployment. You need to deploy it. So for the deployment, MLflow, Kubeflow, Airflow, these are the modules that will come up. Whereas TensorFlow is designed to go ahead and make your model development. It's a framework. It's a framework. TensorFlow is a free and open source software library for developing model, but nowhere they mention that is for deployment. Helpful?
I have a quick question. How
Yes,
much of a
please.
cloud, how much of a cloud exposure we have to do? So you'll be doing MLOps in Azure or AWS or Google, and how much of a cloud services we'll get to know for
Very
MLOps?
fair answer. I'll give you a very fair answer. Cloud
Mhm.
is just an option from my side. But since the real production systems run on cloud, we need to have some or the other kind of a skill on the cloud environment. So what I said, if you want to get started to do training directly onto the cloud, Yes, you can do cleaning, but the kind of risk is good amount of billing will happen into your account, because if you start using ML flow, Kubeflow on AWS cloud, the bill is going to be exceedingly super high. Maybe thousands of dollars you will have to incur. So what I would suggest you, thoroughly build your skills on Kubeflow, ML flow using local setup. That means on your local machine you practice. On your local machine you practice. Once you go ahead and practice on your local machine, take the same piece of model develop that you have done into AWS cloud, or you can take it to Azure cloud. You can take it to Google cloud. This way, you build your skill and export that skill to every other cloud. This is a kind of track. If you follow, you will learn a lot of things. Apart from that, you will save huge amount of money without worrying about the billing into your account. You can happily practice on your local, because everything is free on your local setup, because we will use mostly free tools on your local setup only. So you don't need to get billed from AWS, Azure, or GCP. Krishna, is that okay?
Okay. Yeah. And so for coming to CI/CD, uh, if you're not doing in cloud, how will we do this ML ops, like the CI/CD, if we change any code or anything
Jenkins.
in Mhm.
Jenkins. If you ask me, I will do very powerful way of getting done involving Jenkins. I can show you end to end, right from the code commit done from the developer. We make the changes accordingly, and we get that CI/CD built in the form of a Docker image. The image getting built, published into container registry of Docker image or ECR of AWS cloud. From ECR, we pull it into Kubernetes or part of the Kubeflow or ML flow. For this entire Jenkins is going to be used. So you don't need any cloud machines. And the billing, completely zero. Zero billing.
Okay.
Can you do the same thing in the GitHub action section at CSCD part?
Yes, we can do that in GitHub action sections. The piece of code that you write in Jenkins, you export into YAML file in your GitHub actions. Though it
Yeah,
is
I
not
mean,
part of
most of the JDs I saw uh, more than Jenkins, it is GitHub actions are there
right.
for
I
CSCD.
completely agree with you. No worries. I completely agree with you. If you want, we can have a separate session on GitHub actions where we can write via the GitHub actions getting deployed into. But once again, we need to identify the target in mind. See, GitHub actions will me helping you maybe to the do the build process, but asking a deployment means a kind of a server. That server should be somewhere on a local to that of a cloud machine. We need to figure it out. Yeah. So participants, are we clear now with these concepts?